Okay, so here's how we're going to do the proportional reasoning. These, hopefully you got this in class. I'm just going to go ahead and write these in. 1 halved would be half, third and quartered. Equal and same would mean the same thing. That would get a 1, doubled gets a 2, triple gets a 3, quadruple gets a 4. Okay, we went over that in class. Okay, so these calculations, in case you missed it or need to watch it again, the resistance in a circuit is 10 ohms, so that's the original. Okay, when a 9-volt battery is attached. Okay, if the resistance increases to 30 ohms, okay, what would be the new voltage? And we're keeping the current the same. Okay, so like we really don't care what it is. We just care that it's the same, so that's going to get a 1. Okay, 10 to 30, that's going to get a 3. Okay, this current gets a 1 because it's the same. Okay, so I need to put something here that will be 1 times 3, so that's going to be a 3. Okay, so I can see that that coefficient is going to be a 3, so my new voltage is going to be 27. Okay, so when I write it down here, this is what I'm looking for. So I say 3V, okay, 3 times the original value of 9 volts is going to be 27 volts. Okay, all right, and then written description, I would say when the resistance is tripled and current stays the same, the voltage must triple as well. I do not know what is wrong with my pen. Okay, all right. Okay, number 2, a 6-volt battery drives a current of 0.3 amps through a resistor. Okay, so a 6-volt battery drives a current of 0.3 amps through a resistor. Okay, what will the current be if the voltage is doubled? Okay, so I'm going to double the voltage, making that 12, but the resistance stays the same. So again, I don't know the resistance, but it doesn't matter because I want it to stay the same. Okay, so the resistance is going to get a 1. Okay, my voltage is going to get a 2. So now what's going to happen to my current, right? I can see that 2 would equal 2 times 1. Okay, so that's going to be doubled. Okay, so that's what I was doing. So I'd put 2I here. Okay, 2 times my original current of 0.3 amps. Okay, that's going to get a 2. So that's going to make 0.6 amps. Okay, all right, so I would say that when the with the same resistance, okay, with the same resistance, if you double the voltage, you will double the current. Okay, which makes sense, right? Because if I double the voltage in the same circuit, right, I have the same resistance, so it's the same circuit. If I push twice as hard, I'm going to get twice the current. Okay, all right, and then the third one, I don't really have space for because we did the thing different. Okay, if the current through, actually, I'm not going to do this one. You can figure this one out, or we're going to do it in class.